All right, let's talk about the invisible science that powers, well, pretty much everything. We're diving into the fundamental difference between two things you use every single second, conductors and insulators.
Okay, so let's start with a question you've probably never really stopped to think about, but you literally trust your life with the answer every single day. Just look at any power cord, right? How come you can grab the rubbery part with no problem, but if you touch those metal prongs at the end, well, that's a whole different, much more shocking story.
So, the answer to that simple and, yeah, shocking question, it really just comes down to two key players in the world of electricity. To figure out the cord, we gotta get to know them first. All right, first up, let's meet the superstars of the whole operation, the conductors. Seriously, think of these things as the superhighways for electricity. They're the open roads that get all that energy exactly where it needs to go.
And you know what? The definition is actually super simple. A conductor is basically anything that just lets electricity pass right through it. Easy peasy. They don't put up a fight at all, they just kind of welcome the flow.
So what's the secret sauce here? Well, it's all about the electrons. See, in a conductor, the electrons are kind of loose. They're not tightly bound to their home atoms. They're free to just roam around, jumping from one atom to the next. It really is like a busy highway where cars can just smoothly switch lanes and keep moving. That's the electric current, just cruising along.
So what kind of stuff are we talking about? Well, the obvious ones are metals, right? Like the copper wire that's inside that power cord. But, and get this, it gets a little more personal. Your body? It's a conductor. Animal bodies too. Even the ground you're standing on. And that is exactly why electrical safety is such a huge deal.
Okay, so if conductors are these wide-open highways, what stops the electricity from just boop, going everywhere, causing chaos? Well, that's where our second player comes in. Meet the insulators. They're basically the guardians of the electrical world.
Yeah, an insulator is the total, complete opposite of a conductor. It's any material that puts up a huge fight against electricity. It has a super high resistance. It does not want that current passing through, and it will do everything it can to stop it.
And how do they pull this off? Well, remember those free-roaming electrons in conductors? In insulators, it's the exact opposite. The electrons are held super tightly to their atoms. They are not free to roam. So when electricity comes knocking and tries to push through, boom! It hits a brick wall. The electrons can't move, so the current can't flow. They're like the traffic cops of the atomic world, just holding up a big red stop sign. And you see these insulators everywhere, and pretty much for one big reason: safety. I mean, think about it. The plastic coating on wires? That's an insulator. The glass or porcelain things on power lines? Insulators. Even a simple wooden handle on a tool. They're all there to do one job: protect us from the powerful conductor hidden inside.
Okay, so we've met our two main characters, right? Conductor and insulator. Now let's put them side by side to really lock in just how different and how important they both are.
I mean, it's really a tale of two extremes. On one hand, you've got conductors. Their whole job is to just let it flow. Their electrons are free, electricity passes right on through. Then on the other hand, you've got insulators, and their job is to stop the flow. They put up that high resistance, they block the current. It's as simple as that. One says go, the other screams no.
So, why does any of this matter? What's the big deal? Well, let's bring it all full circle and go right back to where we started, that power cord. And here it is, the big reveal. That power cord is the perfect team-up of these two opposites. On the inside, you've got the conductor, those copper wires, just letting the electricity flow, doing its job, powering your stuff. But wrapped all around it is the insulator, that plastic or rubber casing. And it's doing its job too, blocking that flow, keeping all that dangerous electricity safely inside and away from you.
And listen, this isn't just about one little cord. This fundamental partnership, this teamwork, it's the foundation of our entire modern world. I'm talking everything from the huge power lines you see outside to the teeny tiny little circuits inside your phone. It's always the same deal: a conductor to carry the juice and an insulator to guide it and keep everything safe. You take one away and the whole system falls apart. None of it works. So I'm going to leave you with a little challenge. Just look around you right now. Now that you know what to look for, how many conductors and insulators can you spot? Think about the lamp, the walls, the very device you're watching this on. You'll start to see this invisible team everywhere, working together 24/7 to protect you and to power your life. Kind of cool.